Hello viewer and welcome to the e-learning classroom. So today we want to look at this setup that is a practical on electricity, and then we have cells here, a switch, we have a jockey or a clip. For this time we are going to use a crocodile clip. Then we have voltmeter, ammeter, a bulb, and then we have the nichrome wire. So we are going to plot a graph of current, voltage against current, and then we'll determine the slope. Remember this graph will give us a curve because her bulb is non-ohmic. That is why you can see the voltmeter is across the bulb, meaning the bulb is non-ohmic, so we'll get a curve. So the first thing, we arrange the apparatus as they appear in our setup. So we have the cells. Let's have the cells. First we have the cells. Let's see what we do there. So we have the cells somewhere here. Somewhere here we have the cells. Then close to the cells we have a bulb. Close to the cells we have a bulb. Then a voltmeter besides the bulb. We have a voltmeter besides the bulb. Then we have an ammeter. We have an ammeter somewhere here, an ammeter there. And then we have nichrome wire. We have the nichrome wire. So our nichrome wire is somewhere here. We have the nichrome wire. I hope you're able to see the nichrome wire. And then from there, we have a switch. A switch somewhere here close to the cells. Somewhere close to the cells, we have a switch. So that is how the apparatus are arranged. So then we do the connection. So the first wire is at positive terminal. So we start from positive terminal of the cells. From the positive terminal we go straight to the switch. From positive straight to the switch, like that. From switch straight to the nichrome wire. So from the switch we go straight to the nichrome. Maybe for the nichrome we can start from maybe you can put it somewhere here, maybe at 10 or maybe at 15. Let's just place it anywhere. So we are done with the positive side. Then from negative terminal we have a wire coming from negative. So a wire from negative terminal going straight from the negative terminal here, we have a junction of two wires. So we have a junction of two wires there. Let's first make that junction of two wires. So we have our junction here of two wires. A junction of two wires. One wire goes straight to the bulb. One wire from the junction goes straight to the bulb. Straight to the bulb. While the other wire goes straight to the voltmeter. Because you're on the negative side, we connect to the negative terminal of the voltmeter. Then from the bulb, we have another wire from negative terminal, or from the bulb. From the bulb, we have a wire coming from there. And then this wire forms a junction here of two wires. Forms a junction of two wires. So we first make that junction. So we make that junction of two wires. So we have the junction from bulb, 2 wires. Then one wire goes straight to the ammeter, meaning on the negative side, because it's coming from negative terminal, straight to the ammeter, while the other one goes straight to the voltmeter. So again to the negative side, because we are on the negative terminal. Maybe we can work with the scale of 0 to 2.5. Or maybe, let's say, for the voltmeter, because we will be observing the brightness of the bulb. Let's say it goes 0 to 2.5. In case it doesn't work, we'll change to 0 to 5. So we are here at the junction, 1 to the ammeter, 1 to the voltmeter. Then lastly, we have a wire from ammeter, meaning from now positive, straight to the nichrome wire at 0. Straight to the nichrome wire at 0. So you can see voltmeter is reading, ammeter is reading. So all our setups are reading. You can see now it's working. So what we do, because we're going to fill this table, let's now start from, we have length of 0, this length here being 0, and then we have 20, 40, 60, all the way. So we'll be taking the readings when they are at those values we are given. So let's start with when it is at 0, meaning the two should be together. The two should be together. Let's adjust it to 0. Let's ensure these two are together at 0. So the two are at 0. Then we are told to measure voltage and current. So remember, once we start, we'll be reading all through. So let me close back here so that we get the readings. The first question is also telling you to observe, to tell us what is occurring as length increases. So you should also observe the bulb, the behavior of the bulb as we increase the length. So let's start from 0 there. We have the two are reading. So we start with the voltmeter at 0. So we are working with the upper scale. So this is these are 10, 20, 30. These are 36 squares. So we have 36 squares. Each is 0.5. 0.05, so that 6 times 0.05, this gives us 1.8. So this gives us 1.8. So meaning the first value there is 1.8. So we record that on the table. 1.8. Then for the current, these are 11 because you're working with the upper scale. So that is 0.21. 0.21. That is at 0. We adjust to 20. Observe the bulb. Observe the bulb as we adjust. Observe the bulb as we adjust to 20. 20 is there. So voltmeter, these are 0. These are 9 squares. So 9 times 0.02, which gives us 0.18. 0.18. Then for the voltmeter, these are 10, 20, 25. So 25 times 0.05, which gives us 1.25. I realize also the first one for the ammeter we might have read wrongly because they were 11. So they were 11 times 0.02. So this one was supposed to be 0.22, sorry for that. The first one is 0.22, not 0.21, because each division is 0.02. We go to 40. So we adjust it to 40. We adjust this one to 40. Observe the bulb also. 40 is there. So for the voltmeter, these ones are, this one is reading 1.00, 1.00. Then for the ammeter, we have these ones are 8. So 8 times 0.02, 0.16. 0.16. We go straight to 60. We go straight to 60. So 60 is somewhere there. 60 is somewhere there. Let's start with the voltmeter. These ones are 15. So 15 times 0.05. This is 0.75. Voltmeter 0.75. Then for the ammeter, these ones are 7. These ones are 5, 6, 7. So we have 7 times 0.02. That is 0.14. 0.14. So from there we go to 70. We go to 70 there. So for 70 voltmeter, we have, these ones are 13. So 13 times 0.05. This is 0.65. 0.65. Then for the ammeter, these ones are around, it seems it's still there. Seems it is still there. It's still there, 7 of them. There are still 7. So it means it is still 0.14. Then we go to 80. We go to 80 there. So 80, for the voltmeter, these ones are 12. These are 12. So 12 times 0.05. 12 times 0.05. This one is 0.60. 0.60. Then for the ammeter, these ones are 6. Is it 6 or still 7? For the ammeter, it seems it's for the ammeter, it seems 6. So these are 6. So we have 6 times 0.02. This is 0.12. Then lastly we go to 90. So we adjust straight to 90, the last one. So for the voltmeter, this one is 0.05. No, this one is 0.5, sorry. 0.50. Then for the ammeter, it is still at 0.12, because there are still six. There are still six, so it is still 0.12. So these are the values we have. Look at the bulb brightness. Look at the bulb brightness. Maybe you can go back so that you see the brightness of the bulb. As we go back, look at the bulb. Observe the bulb. Observe the bulb as we go back, as we reduce the length. Observe the bulb, viewer. So viewers, you can be able to see the bulb. As we reduce the length, brightness is increasing. So viewers, we now use these values to plot the graphs. So we now use these values to plot the graph of voltage against current. Remember, this graph is a curve, so we'll be able to find the slope and also to understand what does the slope represent. We want now to use the values we have here to plot a graph. Actually, it is a curve. So we know since the bulb is non-ohmic, so we want to see the values we get from the graph we get from the values we have. So first we draw the axis. We are plotting a graph of voltage against the current. So we first draw the axis. So we have the axis here. So we have the first axis and the second axis. So we have the first axis and the second axis with arrows. Every axis must have an arrow. So since we are plotting voltage against current, so the first axis we call it voltage in volts, and then the other one is current in amperes. Voltage is the y-axis, current is the x-axis, and then from there we look at the values we have. For voltage, the largest value is 1.8, while the smallest value is 0.5. So let's say up to 2.0, because 1.8 is almost 2.0. So if we use 2 squares to represent 1, we'll have 2 squares to plot 2.0. If we use 2 squares to represent 0.5, that means we'll have 0.5, 1, 1.5, and then 2. That means we'll use around 8 squares. We can use 2 squares to represent 0.2. So that means we'll have 2 divided by 0.2. These are around 20 squares. So we can use 2 squares to represent 0.2. So 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, lastly 2.0. Those are the values for voltage. Then for current, the largest value is 0.22, the smallest value is 0.12. So let's say we are plotting up to 0.2. Up to 0.2, we have, let's say, 2 squares. Maybe if we expand this scale, maybe if we can assume this one is going up to 22. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have around 16 squares, assuming we are going up to 22. So that means we can have, because we have 18 squares, let's see, 22 divided by 16, it's around 1.3. Let's say 1.5, maybe. So let's see if we work with 1.5. No. Let's say 0.1, 0.2, 0.3, 0.4. No. Let's see again. Maybe we can expand this scale for this particular case. Let's say we have times 10 raised to -2, times 10 raised to -2, so that we are plotting up to 22. So if we have with 2 squares to represent 2, we'll have 2, 4, 6, 8, 10. So they not fit. Let's say 2 squares to represent 5. So we have 5, 10, 15, 20, maybe 25. So let's work with the 2 squares to represent 5, so that we have around 5 square, 5. So this is 5, 10, 15, 20, 25, 30, 35. We have expanded the scale so that we can plot easily. So with that now, let's see what we have. So viewers, maybe we can use these values now to find how we plot the graph. So let's say we have voltage here, and then we have current here. So for voltage, our accuracy is 0.02, because we are working with 10 divisions representing 0.2, while for current our accuracy is 0.5, because you have 10 divisions representing 5. So let's see how we fill the values from the table. These are 1, 2, 3, 4, 5, 6, 7. So maybe we have there, and there, and there. So for voltage, let's start with the voltage. 1.8 divided by 0.02. These are 90 squares. Then we have 1.25 divided by 0.02. This one is 62.5 squares. Then we have 1 divided by 0.02. These are 50 squares, small divisions of the squares. 0.75 divided by 0.02, 37.5 squares. Then we have 0.65 divided by 0.02. These are 32.5 squares. Then we have 0.60 divided by 0.02. These are 30 squares. Then lastly, 0.5 divided by 0.02. These are 25 squares. That is for voltage. For current, 0.22. Because we have expanded our scale. Whereby we are saying current times 10 raised to -2. It means all the values here will be times 10 raised to -2. So that means we have 22. 22 divided by 0.5. 22 divided by 0.5 is 44. 44 squares. Then we have 18 divided by 0.5, these are 36. That means the other one will be 32, the other one will be 28, 28, 24, and also 24. So these are the values we have. We can now use them to plot the graph. We can now use these values to plot the graph. So we start with the current, 44 squares. So we have 10. We have 10 here, 20 here, 30, 40. So 44 is here. 44 is here. Then we rise up 90. So 10, 20, 30, 40, 50, 60, 70, 80, 90. So the mark is there. 36 squares. So we have 10, 20, 30, 36 here. We rise 62.5. So we have 10, 20, 30, 40, 50, 60. So we have 61 and 62.5 is somewhere there. That is 62.5. Then we go 32, 50, 10, 20, 30, 32 is here. Then 50. So we rise up 50. So we have 10, 20, 30, 40, 50. There. Then we have 28, 10, 20, 28 here. Then we rise 37. So we have 10, 20, 30, 37 is here. So that's 7.5. That 7.5 is there. Then 28 again. So 28, 32.5. So you have 10, 20, 28 is here. Then we have 32.5. 10, 20, 30, 32.5. 32.5 is there. Then we have 24, 10, 10, 20, 24 here, 30, 10, 20, let's see, we have 10, 20, 24 here, we rise 30, 10, 20, 30, there. Then 24 again, 10, 20, 24, 25, rise 25, 10, 20, 25 here. So these are the values we have. These are now the values we have. So viewers, now with the values we have obtained, these are the points we have obtained from plotting of that graph, and we have there. We have now the points we have obtained after plotting this graph from these points. So we can now complete a smooth curve. A smooth curve. Remember, this is a curve which curves towards the voltage side. So we complete this one now by drawing a smooth curve. You need to be careful now when drawing the curve. You need to be careful while drawing the curve. So this is our curve now, viewers. This is the curve we have obtained for the values of voltage against current for the graph of a bulb. So, and with this curve now, we can be able to determine, to solve the question. So we are told what changes occurs on the bulb as L increases. So yes, we were able to realize that after doing the experiment, as the length was increasing, the bulb brightness decreases. So the bulb brightness decreases. That is as you increase the length, because we are increasing the resistance, hence decreasing the current. Then we are to determine the slope of the graph at the point V equals 1.2. So we go to the point where voltage is 1.2. It's somewhere here. That is the point. Then we draw a tangent at that point. When voltage is 1.2, this is the point here. We draw a tangent there. We draw a tangent at that point. When voltage is 1.2, so that is our tangent at that point. Then for the tangent, we can pick two readable points on the tangent, which we can use to determine the slope. So maybe we can pick this point, can pick this lower point here, and we can also pick this other point here on our tangent. Once you draw a tangent, viewers, it becomes similar to a straight line. So we have the tangent there. So, and then for this tangent we can be able, this graph seems not to be going well. So for this tangent, we can now be able to determine the slope. So let's start with the lower side here. These are 10, 20, 25. These are 29 squares. So 29 squares times 0.5. That is 14.5. 14.5. Then on the upper side it is at 0.8. Then for the second values here, we have, this one is 20. Then on the upper side we have 1.5. 1.5. Those are the values. So from there now we are turned to determine the slope. So we know slope is given by change in voltage divided by change in current. Slope is change in voltage divided by change in current. So it will be 1.5 minus 0.8 divided by 20 minus 14.5, but for the denominator we have times 10 raised to power negative 2. Times 10 raised to power negative 2. So the slope becomes, so let's see, 1.5 minus 0.8, then divided by 20 divided by into bracket. Let's work with the two brackets. 20 minus 14.5, close the bracket, times 10 raised to power negative 2, close the second bracket. So this one becomes 12.73. And because we are working with the voltage of a current, that is ohm. Ohm meaning the resistance, ohm. Then what physical quantity is represented by the slope of the graph at any point? So the physical quantity represented is the resistance. Resistance, because we are dividing slope voltage all over current. So viewers, that is what we have for that practical. Those are the values we have, and also the working for that particular practical and the curve we have obtained. So that marks the end of today's session. I wish you all the best.